In this video lecture, we'll take a look at how to begin testing the new person class that we're gradually building up. Okay, let's get started. Okay, so thus far our new person class has an instance variable, two overloaded constructors with which to create new person objects, and two display methods so that we can see inside our class. We're kind of at the point now where we need to be thinking about how to begin testing this class or putting it to use. Keep in mind that any new class we write is simply another reusable software component. We can use it to create new objects of whatever class type it is, just as we've done with CS12date, scanner, string, and a handful of other Java classes. So we can use our new person class just as we would any other Java class, and there are a couple different ways of doing this. As shown down here in Figure A, we could use our new person class as an object within the main method of some client application class. Here, let's imagine this little green OBJ box as being a new object instance of our person class, but more generally it could represent any type of class. This is exactly the structure you've used in most of the prior homework assignments so far, except you've used different types of objects, for example CS12date, scanner, or string. As shown in Figure B, we can also use objects within any other methods, such as you probably did on your methods program, where you embedded a scanner within one of the methods to get user inputs. In truth, this is actually just a generalization of Figure A, because of course main itself simply a method, although a very key one that tells Java where to begin program execution. So now I'm going to rock your world a little bit and say that we're going to add a main method inside our person class, appended to the end of our class code, and it's going to serve as some unit test code. This sort of flips everything we've done so far on its head. Up to now, a main method such as here was the core of all our programs, and that's where all our program code went. Now the focus is on our new class as being a standalone component destined to be used elsewhere, and now main is subordinate to the rest of our class code, intended only to be used as a test driver. All this green code on the top represents all the smarts behind each new little object of it that we use elsewhere. I've found there are some distinct advantages to this approach. All the class code and all its test code are self-contained into one file. There's no extra test code file needed, and we can gradually add lines of test code to our main as we implement new features, so that we can build a little, test a little. As I've said before, there's nothing worse than writing dozens or hundreds of lines of code over some period of time, only to find out you've introduced all kinds of problems into your new class. It's far preferable and much more efficient to incrementally test your changes as you make them, so you can find any problems as soon as possible. For this course then, we will consider it another course coding standard to always add a main method to the end of any new class you write, and use it to test your class as you add capabilities to it. Let's see what this might look like. Here at the upper right, we see an example of what our unit test code might begin to look like. As you look this over, realize that this is nothing more than a standard main method of any Java application, as it might appear in any new class we write, except that here we've chosen to co-locate it at the end of our person class file. The big idea of our testing approach is that we're going to test out all methods as we create them elsewhere in this class file. We've implemented two overloaded constructor forms so far, so we're going to instantiate objects with each one of them. Once we have some new person objects on hand, then we can test our display methods to see inside our objects. Here we're checking out toString implicitly, which gives us this first result, then the default print, which gives us this second result, and finally the overloaded print, which gives us the same result except preceded by this header. We might not need to test every display method on every object, but we should display each object created somehow. The intent here is that as we gradually add each additional new API capability step by step, part of that will also be to add a few more lines of test code, so we can test each new feature as we add it. If we build up this unit test code gradually like this, it's much easier than trying to scramble to write it at the end. And as a bonus, we can always easily retest our class as we make changes to it over time. I've found over the years that this kind of build and test approach seems to save a lot of time and frustration over the long haul, and leads to better, more robust code. I strongly encourage you to adopt this approach for this course and early in your potential professional lives. Please take a moment now to pause and view the demo video for Person Phase 5.java, where we'll demonstrate setting up and executing this test code for our person class. Come back to this video when you are finished. When you're using a main method at the end of the same file to test some new class, such as person, here are a few things that you must keep clearly in mind. As shown here on the right, there is effectively an unbreachable wall between the two sides of the same Java file. What this means is that nothing in this main method test code can directly access anything on the other side of the same file, except via created objects as usual. So for example, main cannot directly access any of the instance variables, nor can it directly access any of these methods, even any public accessors or mutators, even though they all appear within the same source code file. Remember that main itself is a static method, and there's that restriction that static methods can only directly call other static methods. If you go back to look at the methods program you wrote, you'll see that all those helper methods were static methods themselves. The only way to make use of the class code above is by instantiating new objects of that type, and then calling the available public API methods using dot notation, as we see here. If we want to get at the data, we would use the public accessors and mutators. This is simply how object-oriented languages protect and manage their own data and methods. Speaking of accessors and mutators, let's next take a look at how to implement those in our growing person class.